Hello, in this video, let's learn how to solve for x in this nice exponential equation. We're asked to solve for x in 3 to the power of x equal to x to the power of 9. Now, if you look at this expression, you find out that the exponent of the left-hand side is equal to the base of the right-hand side. So how do we carry out the solution to this expression? Join me as we solve it. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. So the first thing we are going to do is to make sure that we reduce any of the index from the left hand side or the right hand side. So to ensure that, what I'm going to do is to simplify both sides by multiplying both sides by 1 divided by 9x. Now see what I'm going to do. I'm going to multiply both sides by the power of 1 divided by 1x. 3 to the power of x multiplied by 1 divided by 9x, and that will be equal to x to the power of 9 multiplying 1 to the power of 9x. So where will I arrive at? If I do this, I'm going to arrive at, remember the law of indices. From the law of indices, the exponent will have to multiply, and the exponent will have to multiply. That will now give me 3 to the power of x multiplying 1 divided by 9x, and this will be equal to x to the power of 9 multiplying 1 divided by 9x, right? Now we will simplify. X will have to cancel out x, and 9 will have to cancel out 9. Now I've achieved something on the right hand side. You know what I've achieved? I've achieved a situation where I have the base having almost the same expression as the power. Now from the right hand side, I've made this to become 3 to the power of 1 divided by 9, which I can also simplify further. So what do we do here? Guess what we'll do here? Pause this video a little and try looking at a solution to this before you continue watching this video. Now, what I'm going to do here is I'm going to apply a simple logic. And what will that simple logic be? Now, if I simply simplify this, I can simply simplify this to give me 3 to the power of 1 multiply 1 divided by 9, right? I've not changed anything, and this is equal to x to the power of 1 divided by x. Now recall that my 1 can be equal to 3 divided by 3. It's logical. So if I replace that 1 with 3 divided by 3, I've not changed anything. So that will give me 3 multiplied by the power of 3 divided by 3 multiplying 1 divided by 9. I did not change anything, and this will be equal to x to the power of 1 divided by x. Great. Now, according to the law of indices, I can carry out some uh, some indical steps here, and what I'm going to do is I can simply simplify this to become this can become 3 to the power of 3, right? 3 is a power, and this will be 1 divided by 3 multiplying 1 divided by 9, right? And this will be equal to x to the power of 1 divided by x. Now you see what I'm trying to achieve. I want to make sure that I have same power and same base. The same thing the right hand side is. So this will give me 3 to the power of 3 is going to give me 27, right? So I have my 27 to the power of 3 times 9 will give me 27. So I have 1 divided by 27. And this will be equal to x to the power of 1 divided by x. Great. I've achieved what I desire to achieve. Now, looking at this now, I can simply compare the base and the exponent. If I compare the base and the exponent, I'll have 1 divided by 27 equal to 1 divided by x, of which if I simplify by cross multiplying, my x will be equal to 27. Now if I compare the base also, my x in the base will be equal to 87. So that tells me that the solution to that expression is x equal to 27. And that is the solution to that math question given to us up there. Now I want to check if my solution is absolutely right. So what I'm going to do is I'm going to insert the value of x into that expression. The original expression given to me is 3 to the power of x equal to x to the power of 9. Now I want to insert the value of x equal to 3x into that expression to see if I will get the original expression. So I'll have 3 to the power of 27, that's to check, equal to 27 to the power of 9. Now can this expression really give me same value on the left hand side and the right hand side? Of course it can. So I will either do it in a two-way thing. Now I will check this expression to become 3 to the power of 3 multiplying 9, right? And this will be equal to 27 to the power of 9, right? Now this can be 3 to the power of 3 multiplying 9 equal to 27 to the power of 9. Now this can give me 3 times 9 can give me 3 square can give me 27. So I'll have 27 to the power of 9 equal to 27 to the power of 9 equal. So that tells me that that expression is correct. Or I can do it the other way around. I can reduce this, right? I can also reduce this to have my 3 to the power of 27 equal to this can also be reduced to give me 3 to the power of 2, and once I reduce that, I will be able to have an expression in which I'll have 3 up there. Now 27 can give me 3 to the power of 2 times 2, 3 times 3, 9, 9 times 3, that is 3 to the power of what? 3 to the power of 3 multiplying 9, and this will give me 3 to the power of 27, and this will be equal to 3 to the power of 3 to the power of 3 multiplied by 9, and then I'll have my 3 to the power of 27 equal to 3 to the power of 27. So whichever way you take to check, you'll find out that the value of x equal to 27 is the solution that satisfy that exponential equation given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.